Well, thanks very much for giving me the opportunity to talk today a little bit about my work and the contribution to work package 2. And I'm guessing that you've all, come on, it's a bit, yeah. I'm guessing you've all seen these nice infograms that Anna has created and describes a little bit about the work that we're planning to do on this particular work package with a sensor that attached to the tree and measures some variables that we hope to be able to transmit and be able to visualize and sonify, if that's the word correct, the correct word. But today I'm only going to talk a little bit about understanding the data that we've collected so far from our site up in Harwood Forest, which I was responsible, and I'm still responsible, and some other data that I've collected over the years on different aspects of tree growth. And my interest to do the project came mainly because I have two kind of personalities, let's say, the scientist and the artist, and I've always been very interested to try to bring those two together, because sometimes the science I'm doing can be a little bit difficult to explain to people. And so I thought, well, if we can bring these two together, it will definitely bring a very big interest on what I'm doing and try to explain to people what exactly it is all about. So, as you probably already know, and I don't need to explain too much about that, we know that forest ecosystems offer a lot of things to us, and what we call ecosystem services. So amongst of those are, of course, the carbon sequestration, the climate regulation, food regulation, stability, constructional timber, and all sorts of other stuff. But my research is mainly focusing on the carbon sequestration, so how much of carbon from the atmosphere the trees are absorbing, how by the climate, but also affect the climate as well. And a little bit as an extension of all that, the provision of constructional materials, in particular timber. So what are the important issues with forest ecosystems? For me, the key issue here is climate change. And we know, all of us, that climate change is happening, and we cannot deny that. And these are the data that show us exactly what is climate change. This is a particular example from the 2018 data. So these are real data collected by the Met Office, which clearly shows from the left-hand side, you can see here, this is the temperatures. So we have a very cool, colder winters. So this is the deviation from the average, from the long-term average on this particular year, and very hot summers. And also in terms of rainfall, we're going to have a lot more rainfall during winters, but a lot drier spring and summers. So climate change is not always about the actual numbers, but also it's about the distribution and when these differences are going to happen. Okay, and all these are affecting our forest ecosystems. And the other impact we have as human beings on forest ecosystem is the land use change. And in particular in the UK, in Great Britain, we have this what we call clear felling method of managing our forest. So you see we have a very, very mature forest which we clear fell, and we're changing how the landscape is looking. And you can see here at the top, these are data from a satellite from a few years back, where this is a big Sitka spruce plantation, and you see the pink is where we actually felling trees, and the blue is where we actually planting new trees. So we are changing the landscape. So there's two big elements that I'm really keen and exploring with my science. So the reason, and the other thing is that I'm really focusing on conifer plantations at the moment, because we, like it or not, most of the forest in the United Kingdom and Great Britain in particular is conifers. As you can see, almost half of the land is covered by conifers. And if we look at the public forest estates, so the land that Forestry England and Forest and Land Scotland and Natural Resources Wales is managing, more than half is one particular species, Sitka spruce. So we kind of think this is a very important element that we need to keep looking and see how it does in terms of carbon sequestration, how it grows, and how climate change is going to affect this particular type of forestry, because it is very essential and very big for the country. And so we've have this area where we've been looking for many years. Now we've been monitoring. It's called Harwood Forest, which is located in Northumberland, a little bit north of Newcastle. And it's a very old area, very old plantation that was established in 1930s initially. And it's always been a conifer plantation. It's always been a Sitka spruce plantation. Over the years, it has been expanded. So it offers us a good base of doing this important research on a typical forestry for the UK. And what we measure, probably you've seen this last time when Matt explained about the Alice Holt information, but the key important thing for us is always the exchange of carbon between the atmosphere and the forest ecosystem, and not only the total exchange between the two, but also different fluxes within the forest ecosystem, how they photosynthesize, how much of that carbon is going into different components of the forest, so we can understand then when climate is changing, what are the changes and what happens. And of course, how our management also affects these fluxes as a total. And again, you probably have seen already through your visit to the Alice Holt site, where we do that with these long structures, these towers. And we had similar structures at Harwood Forest. Actually, we had two, one which was in a mature Sitka spruce and one which was in a felled stand. And on top of that, we have a series of automated instruments, which, again, probably you've seen this. So I'm kind of reiterating what Matt is, but this is a kind of the work that Forest Research was strongly focusing. So as you can see here, we had all the analyzers where they're measuring the CO2 concentrations and water concentration and all other variables. But the neat thing we did for our side was that we managed to bring all this information together with assorted climatological variables like radiation, temperature, rainfall, put them all together in a small processor, process the data online on the fly, and push them towards the cloud, all these variables, and then we could download this data on a nice platform. We can visualize the data, so we had constant feed of what is happening on our site constantly, and we can see changes as it was happening, which was really, really neat process. And so what did we see from that? You know, we've been monitoring that site constantly for 4 years, from the 2015 and to 2018. And of course, 3 years after that, which I don't have the data at the moment, but what it is important for you to show here is that in terms of forest management, we've been seriously impacting the forest ecosystem. So like if we focus here on the net ecosystem exchange, which is the total carbon absorbed by a forest ecosystem, the negative value shows absorption, the positive value shows emission. Okay, so when we have the mature trees, they absorb about 7 tons of carbon per hectare per year, and the same amount was emitted when we cut the tree. So to me, that's a very important information that we need to take across not only to our forest industry, but also to the public, to say this is what is happening to our forest, this is the impact we have by managing our forest. And so it is important that we need to change the culture of how we do forest management in the future generations. And by keep monitoring the site over the years, we've seen that, okay, the forest was really growing very well, whereas the site that we felt in the beginning of 2015 was starting to recover. By recovering, I mean, it was emitting less and less every year in terms of carbon dioxide. And that's because new trees were starting growing, natural regeneration. There were a lot of grasses. So there was a lot of photosynthesis happening there as well. But we were very unlucky in that sense because we got the 2018 drought, which wasn't planned, but it allowed us to see what's the impact of natural extreme events such as that one. And when we look at the values, we saw that there was a significant drop in the carbon absorption by the forest ecosystem, by the mature trees. And also there was a significant release of carbon from the felled trees back to the atmosphere. So initially the felled site was going to be a nice absorption site, so what we call a sink, but it went back into a release. And so we saw about a 30% drop on the absorption of carbon because of the drought in the mature sand when we compare it with the previous 3 years. So that got me thinking, and I wanted to look a little bit more into why and how this drought is happening. And this is a different way to visualize all the continuous data that we've collected those 4 years. So here at the top, you can see how the moisture in the soil goes. So you can see very nicely patterns across the season. This is summer, this is winter, summer again here. And here you start seeing in 2018, the drought. There is a lot of water uptake by the trees. There is very little precipitation happening here, and suddenly it reaches a very, very low percentage of moisture. And why is that? Because during that year, you see there's been very hot weather, there's been quite a lot of radiation, and this is the radiation here. Oh, and I should explain that these graphs show you also both the variability in time, but also the variability in time in time of the day. So you can see here the day length, how it increases over the summertime, and then during winter time where you have shorter days. And so you can see which year you have higher values and also what time of the day. So about midday is always when we have most of the photosynthesis, when we have the higher radiation. So going back to 2018, we saw that there is a lot of loss of water from the trees. That's because trees, in particular the spruce, Sitka spruce, has been growing really fast, has been very happy, and suddenly there is not a lot of precipitation. So all this water that was moving from the soil up to the atmosphere suddenly started creating a lack of water in the soil. And at that point where you see the dashed line is where the trees essentially stopped growing because there wasn't enough water. There was a very high period of sunshine and a lot of heat, and the trees simply, if you see here, they stopped growing. Okay, and they meet the release of water, so how much water was lost was also dropped because of that. So that again, it got me thinking, how and when the trees are stressed, because this is a key important element when we're looking at the climate change and the future existence of our forests. When our trees are stressed, what is happening when they are stressed, and can we demonstrate when our trees are stressed? So there are a lot of processes happening during that stress period, but the key important thing for me is whether you can monitor the balance between how much water the trees are receiving versus how much water the trees are absorbing from the soil and putting back into the atmosphere. And there are different ways you can do that. You can do it and also at different scales. So you can do it either at a leaf level, you can do it at tree, and you can do it at ecosystem level with the flax towers that we've been looking. But whatever we do, it's really important to have a drought monitoring system. So it's a system that you can have continuous measurements that come as real time as possible, and we can look at all the processes of the forest ecosystem depending on the scale. But we need to look at soil, we need to look at tree, and we need to look at the actual atmosphere. So these are now the data that I think they are really critical for using in sensing the forest. And so to understand what the data are telling us, it's really important first for you to understand how water is moving through the forest ecosystem and through a tree. And it's very simple. And you can imagine a very simple electric circuit. So as you can see here, we have an electric circuit. We have a difference in voltage. We have the circuit that electricity moves, and there is some resistors that produce resistance to the movement of electricity. So if we go to an equivalent of a forest ecosystem, it's exactly the same principle. Water moves with exactly the same principle, but rather than having a potential difference in voltage, we have the difference in pressure between the soil and the atmosphere. And the resistance can be either the soil, can be either the roots, the stem itself, the leaves, or as we can do that as a total plant resistance. So if we can monitor the movement of water within the soil and the movement of water within the plant, then we can understand and characterize how much resistance and how much difficulty they experience as they progressing through the different stages of growth and through different environments. So how do we measure the water flow in trees? Well, very simply, it's what we've been talking, and Anna was talking about earlier. It's about the subflow sensors. So these sensors, this particular method we have here, we have 3 needles, one which provides heat, and 2 needles which are essentially thermometers. And as the heat is produced and water is moving up from the roots to the leaves, the heat is moving, and there's a difference in temperature that these 2 sensors are measuring. So this temperature will be lower than this one, and so we know that there is a positive flow moving upwards. And you can do that only on the part of the tree that actually transports water, which is what we call the xylem. Whereas the old part with the hardwood, every year there's a new xylem is produced, and the old part of the tree is becoming non-functional anymore. So there is no water nutrients moving up and down on that part, and that's the hardwood. And so using these sensors, we can, as I said, over a few months, we can monitor the water uptake of the trees from different types of trees and different sizes. So for example, here you see we've done it in young trees in pots, where we water them. We've reached a point where they have a very nice enough water in the soil, and you can see how the daily variation of water uptake is moving, from the soil up to the trees, and we can see that is in liters per hour up to 0.07. Okay, and you can also see that it's a little bit of a lag between when the water is saturated in the soil and the peak of the water that is going up the trees. And then we stop watering the tree, and you can see also how the trees are responding to the lack of water. And we can do that for different trees and different intensities. The same can be done in big trees, and we've seen this with 3 different trees in the field where we were monitoring different levels of moisture. So this is naturally in the same site, but they are in different locations within the same site. So this tree has been in a very wet part of the forest, whereas this particular tree, it was in a drier part of the forest. And so you see the one that is very well watered doesn't transport a lot of water, whereas those ones can transport up to 8 liters per hour. So these are big trees, and the amount of water they transmit is a lot. And so we can see both the variability within the day and also within time. And when we put all this information together, again, we can put them as a single unit, as a single index, where we can say whether these trees have been stressed or not. And this water deficit index, for this particular tree, it tells me that there is a lot of water uptake. You can see it can go up to 6 liters per hour, but the amount of water that there is in the soil is sufficient to support that water uptake from the tree. Whereas if you look at another tree, the amount of water that is uptaken by the tree is a lot less than the previous one. It can go up to 4 and 5 liters per hour, but the amount of water in that soil is a lot less, so the tree has a deficit, spends under deficit a lot longer. So, to conclude, how do we raise awareness of all this information? And that's why you see all this information. To me, it's always very difficult to take them aboard to all different audiences, and how to make them understandable, and so we can raise awareness for the future of our forest ecosystems. And that's why I think the Sensing the Forest project is really key here, and I'm really keen to see whether we can achieve that by transforming all this information into something that is really understandable by everyone. And if I can put my artist hat here, that's what I really want to make a music and a sound representation of my data. And this is my attempt of that with the music. And if I can, I don't know whether you can hear. Yay! So this is a sonification of this data. So it's the carbon uptake from the forest, but in combination of other variables as well. So it has temperature, it has solar radiation, and it has precipitation. All these coming, and they provide a more, and you can see the patterns goes up and down. So this is an interpretation of the data using scales, different scales, and different instruments. So every variable represents a different instrument, and you can hear how the period is changing from different year, from one to the other. So this is what I'm hoping from Work Package 2. Thanks.